Hello viewers, welcome back to our YouTube channel. We are still on the properties of binary operation, and in today's section you are going to learn about the inverse element. We say that an element a exponent negative 1, which is a member of R, is called the inverse of a, which is also a member of R, under the operation star if a star a exponent negative 1, which is the inverse of a, is equal to the inverse of a star a, which is equal to e. So it means that we say that a number or an element is the inverse of a certain element when, if we perform operation on those two, we are going to get the identity element. So if you perform an operation on an element and its inverse, you are supposed to get the identity element. So if you perform it and you don't get the identity element, then it means that what you are getting is not the inverse of the element. So I want us to draw our minds back on the basic operations that we know, like the addition, multiplication, subtraction, and division. If I should ask what is the inverse of 2, what is the inverse of 2? Most of you will say that it is 1 over 2. 1 over 2 is not wrong. It is correct because when I asked, I didn't state any operation to it. So for the basic operations, addition, subtraction, multiplication and division, they move in pairs. So addition and subtraction move in pairs, and multiplication and division also move in pairs. Normally when you are performing an operation, you are solving an equation, let's say you have 2x plus 1 is equal to 5. If you want to take this plus here to the other side, you realize that it comes here to become minus, which is 5 minus 1. So you realize that when this one came here, it has become minus. And also if you have something like 2x is equal to 4, now 2 is multiplying here. If you want to send 2 to the other side, you will see that 2 goes to divide. Yes, so we say that subtraction is the inverse of addition and division is the inverse of multiplication. So if you have 2 and you are told to find the additive inverse of 2, it's supposed to be negative 2. Because we are saying that whenever you perform an operation on an element and its inverse, you have to get the identity element. And in our previous video, we learned that the identity element for addition and subtraction is 0. And here 2 minus 2 is going to give us 0. So if you have 3 and you are told to find the additive inverse of 3, it's supposed to be negative 3, because 3 minus 3 is going to give you 0, which is our identity element. Now let's come to the multiplication side. In a previous video, we learned that the identity element for multiplication is 1. So it means that if you perform an operation on an element and its multiplicative index, you have to get 1. So in this case, if I ask for the multiplicative inverse of 2, it's going to be 1 over 2, because 2 times 1 over 2 is going to give us 1, which is the identity element of multiplication. If I ask for the multiplicative inverse of 4, it is going to be 1 over 4, because 4 times 1 over 4, 4 will cancel 4, so it's going to give us 1, where 1 is the identity element of multiplication. But then for other operations like the star, the dots and the rest, since we don't have a generalized way of doing it and we are giving rules, like rules which are made up of the basic operations, we use those rules to find the identity element. Sorry, the inverse element. So let's try to look at some examples of it. So let's see this example. The operation star is defined over a set R of real numbers by A star B is equal to A plus B plus AB. So here we have A star B is to be equal to A plus B plus AB. Now, for all AB, which is a member of R, find the inverse under the operation star of a general element A which belongs to R. So it's like we are just finding a general element A, and A belongs to R, so A can be any real number at all. But for here, we just want to find a general element for it. So let's deal with the first part of the question. So we said from the definition of the inverse element, we saw that A star A inverse should be equal to E. So for us to be able to solve this, we have to find the identity element of this operation. So we are having A star B to be equal to A plus B plus AB. So we are going to find our identity element. So to find our identity element, we said that any element star, the identity element should give you the element itself. So we are come to put this into the rule. So here we get A plus B, sorry, A plus E plus AE is equal to A. So we send A to the other side. So A minus A will give us 0. So you end up getting AE plus AE to be equal to 0. Then here we end up getting we factorize E out, you get 1 plus A to be equal to 0. So our E is equal to 0 over 1 plus A. And then any 0 over any number is 0. So it means the identity element is 0. So now here our E is 0. So we also put this into the rule we've been given here to find the inverse of A. So here we are going to get, let me move on to the next page. So we said that our E is equal to 0, A star B is equal to A plus B plus AB. Then now we know that A star A inverse is equal to E. So we are come to put A star A inverse into the rule. So here we'll get A plus A inverse plus A inverse is equal to our E is what? 0. So our main aim is to find A inverse. So we are going to take A to the other side. So we are going to get A inverse plus A inverse is equal to, this is positive here. So when it comes here, it becomes negative. So you are going to get negative A. So we are going to factorize A inverse out here. If you factorize here, we are going to get 1 plus A, which is equal to negative A. So our A inverse is equal to negative A all over 1 plus A. So our A inverse is negative A all over 1 plus A. So that's the first part of the question. We are asked to find the inverse under the operation star of a general element A. So that's what we found. And the next one is state which element has no inverse. Now, A is a set of real numbers, right? So it means that we are going to look for a certain real number that when we put in this equation, we are not going to get its inverse. Now we know that any number over 0 is undefined, right? So it means that we are going to find a value a value for A, which when we put in the denominator, we are going to get 0 because any number over 0 is undefined. So it means that that number doesn't have an inverse. So it means that we are looking for a number which will give us the denominator 1 plus A to be 0. So we are going to look for a number that will give us the denominator 1 plus A to be 0. So now we have 1 plus A to be 0. So it means that A is equal to what? Negative 1. So it means for the element negative 1, we don't have an identity element for it, because if you come and put negative 1 here, our A inverse will be equal to negative 1 all over 1 plus negative 1. So here we end up getting 1 over 1 plus negative 1 is 0, and 1 over 0 is undefined. So we can't get an inverse for the element negative 1. So that is it for the second part of the question. And the last one is telling us to find the inverse of 1. So from here, we've been able to find the generalized inverse for any element A which belongs to a set of real numbers. And since 1 is a real number, we'll come and put 1 inside what we've gotten here. So the inverse of 1 is equal to, wherever we see a, we are putting 1 there. So it's equal to negative 1 over 1 plus 1, which is equal to negative 1 over 2. So our inverse of 1 is negative 1 over 2. Yeah. So that is it. So I would like us to solve one more question here. So from here to, we have a table, and from this table they are saying that the operation star defined on a set of raw numbers s is equal to abc by the table below. Determine the inverse of each element of s under star. So you are going to find the inverse of a, inverse of b, and inverse of c. Now from here we said that for inverse a star, a inverse should give us the identity element. So here we have to find the identity element here. We solved this in a previous example, in the previous video when we were doing the identity element, and we got our identity element. So for the identity element, we said that anytime you do the identity element and you perform an operation on the identity element and any element, you should get the element itself. So here a star a is a star b is giving us b, our b here. A star c is giving us c, our c here. So it means that our a becomes the identity element, because whenever you perform an operation on a with any of the elements, you get the element itself. So we say that our identity element here is a. And we are saying for inverse, a star a inverse should give us a. So whenever you do a star a inverse should give us the identity element. So we are going to look for each of the elements. So if you have a, what star a is going to give us the identity element a. That would be the inverse of a. What star b is going to give us the identity element a. That would be the inverse of b. What star c is going to give us the identity element a. That will give us the inverse of c. So from here we can see that a star a is a. So a star a is a, where a is our identity element. So here is our inverse. So the inverse of a is a. Let's come to b. Now b star, what is going to give us a? B star c is going to give us a here. So b star c is going to give us a. So c is the identity element, is the inverse element of b, because b star c is going to give us a, which is the identity element. Now let's check for c. C star, what is going to give us a? C star b. So c star b is giving us a. So which means that b is the inverse of the element c, because c star b is giving us a, which is the identity element. So that is all about the inverse. So it's like we are just looking for a value, or value on an element, that if we perform an operation on the element we are having already in the inverse, we are going to get the identity element. So that will be it for today. If you have any questions or any contributions, please let us know in the comment section. See you in the next video. Bye.